This video series is about using a product called OMNIKEY 3121, and this is a contact card reader writer. I'm going to show you how to do the installation and to download the required software and documentation. And I'll be using two contact cards. One is the SLE 4442 or 5542, and other one is SLE 4428 or 5528, and also be showing you the demo software that comes with this product as well. And finally, so we are going to see how to use both the cards, so using my learning tool, the contact cards reader writer. If you do not have the OMNIKEY 3121 reader writer, I would advise you to now pause the video and go to eBay and buy this product. So somebody here, one of the seller here is selling this for £8, and I already bought a few for my training center, and this is really a good price to buy. Now this is the main product page. You have to go to the HID Global website, and from here you can download the drivers and the required documentation and the software. So in fact, most of these devices, they don't need any drivers if you are using the Windows operating system. So my laptop here runs on Windows 10. Now after you do the installation, you have to go to the drivers and the download section, and you have to download or search for the Synchronous API. You can search here, and this is a very good software to have if you want to learn how to program the contact cards using OMNIKEY 3121. So there are two versions here. One is for the Windows, so it's this one. This is for the Windows, the 32-bit version, and this is the 64-bit version, and this is called the Synchronous API, because in order to program using these type of SLE 4442 tags, so you need this Synchronous API. However, there is one more way which I'm going to show you soon. So you can use this ISO commands to communicate with this 3121. Now before I continue, I would like to mention about some of the videos I have already made, and they are available in YouTube. So I have made I've covered everything in detail about the SLE 5542 and 4442 or 5528. So it is in a playlist called Understanding and Programming Contact Cards and Contact Memory and Smart Cards, and these videos have got everything in detail. So however, I have used a different reader writer, and that is the ACR 39U. Oh, you can see here I've connected my 3121 device, and what I noticed in this item from eBay is when you buy, you do not get a vertical stand. So for me, and probably for students who want to learn how to use this, it doesn't matter. You just have to place it flat, and it could be for that reason probably that person is selling this for £8. Okay, so when you connect this, I've connected here, and this is my device manager, and you should see under your smart card reader node, you should see the OMNIKEY 3x21. Now you don't see this when you connect this device for the first time. So you will see a very generic name, something saying about CCID reader writer. So it's very easy. You just have to right click and give the update driver, and I'm sure you have used this feature, and I don't see the update driver because this login I'm using here is not administrator, so you have to be an administrator to update the driver. So just choose that update driver and choose search automatically. Windows operating system will download the latest driver, and eventually you should see the OMNIKEY 2x21. So you have to make sure that you see this entry. Otherwise, I would say best thing to have this visible. Okay. Now, if you remember, I showed you a page in a History Global website and mentioned about the Synchronous API download. So when you do that, so it will install. That is an installer. So it installs probably some DLLs, and it creates a folder under your program files. It depends on which version of API you installed. I have installed the 64-bit version, so it creates a folder under the program files, HID Global Sync API, and if you go to the samples, and this is where you got the source code on how to use this Synchronous API. So I'll be using the VB.NET, so I'll be seeing this one. If you see here, there is a file for SCAR2W3B. This SLE 5542, so they are called as a two-wire protocol. So something similar to probably an I2C. I'm not very good in this part of the electronics, so I don't comment anything more than this. And the 552, it comes under the three-wire protocol. So if you want to know how to program, this is you have to go through this program. It's very simple programs, and it has got some documentation. And if you go to the help here, it has a document, and I have downloaded, I've installed here. Now you need, this is the Synchronous API documentation, and this is the product page. This is the product data sheet for this 3121, and it is called as a OMNIKEY Contact Smart Cards. So here you have to read this, and also if you look at the description here, it says this document applies for the various reader writer. So we are using the 3121, and we'll be interested in the contact cards. I'll be showing you, I'll be going through this command one by one when I start showing you my software. So you have to read this, and probably you have to read again and again. And if you want to program using the PCSC, you have to follow this document. If you want to program using the Synchronous API, you have to do this. Now this is the Synchronous API, the VB sample which I showed you, and see that is a source code actually. So if you want to run this this sample, you can jump in here, go to the bin folder. There is a exe file application. You can just run that. But what I have done is I have opened this source code in my Visual Studio, and I'm running from there. Okay, so you can, I'm going to show you, I'm not going to go through this because as I mentioned before, I've got so many videos that teaches you the SLE 5542 tags. I'm just going to show you how to use this simple tool. So if you don't have any software, probably you can start this tool. The first is you establish the contacts. All these commands are the PCSC commands. However, you don't have to know, if you're not a programmer, you don't have to know all those details. So hit this button. Now place the tag. Connect it. Just place it proper. Yeah. when you insert the card, the computer should give a nice the beep sound. The connect successful, and you have to choose the type of the card. This is a 2-wire, and I think you will be using 3-wire for SLE 5528. Now I'm going to use a 2-wire. When hit the read data, so probably here it shows you how many bytes you want to read. I'm just going to put 255 and say read data. So the entire 255 bytes of the tag is read, and you have to keep in mind this SLE 5542 or 4442 you cannot write without entering the password, so that's called as a pin. For all new cards, the pin is all 3FF is written here, all 3FFs. Okay, now in order to modify, so I'm going to use first, you're going to use, if you try to write something, so probably I'm going to write from address 50 hex some data A1, A2, A3, A4. So if I hit, in fact, the write data is disabled, so the software remembers you're not authenticated. So I'm going to put, if you hit this button present pin, it is going to send the Synchronous API commands to to authenticate. So I'm going to say present pin. The message here says successful, then write is enabled. If I hit write data, it's a write is successful, and in order to see the data, I'm going to read this card again, probably somewhere down. Okay, it's not. Let me try. Okay, write successful. Yeah, probably I didn't hit that. I don't know what happened. So when you say read data, probably it was a read. I think that was a problem, not the write. So when you hit the read data again, you can see here that data is written. So I'm going to write from address 54, say B1, B2, B3, B4. So from 54, say write the data and read the data. You can see that. So the write is possible only after you present the pin. So if you notice, this software doesn't have these two buttons. Now I have modified this program for these two functionalities. Now one of the functionalities is this pin. To know what these functionalities are, now it's see in this folder there is a documentation about the help, and I've just clicked on index, and these are the various commands available for this 2OR. You can see here it has got a read data, read the protection memory, write the data, compare and protect. Now this is to protect the data. The first 32 bytes of this memory card can be protected. Present the pin, change the pin, you can change the password. Is pin present? If you click here, it tells you exactly what this function is. It says this function checks and returns if pin is already presented. So likewise, there are around 5. You got something called read error counter. So for all these functions, the screen doesn't show to test all these functions. Now, for example, it doesn't have to protect the memory or get the error counter. Say about protecting memory or what is the error counter, please see my videos on SLE 5542. I've covered everything in detail. Now, so I've added this function. Okay, somehow I just want to mention that I could not get this protect memory using this Synchronous API. Assume that I want to protect the memory at address 12, 12, that's 18. If I want to protect it, I've written a program, I get this error. Now I've still I just want to let you know that I just somehow could not get this protect memory working. So however, all these functionalities I have shown, they all work using this ACR 39X reader writer. So that is all about this software. And just now mention again, if you're a student or software developer, please go through those the samples. You'll come to know how to use this API. So in this document, there is a section about the synchronous card support. Now I've used all these standard PCSC commands: read binary, update binary, the verify, the read protection memory, compare and protect, and modify. If you look at the read binary, so this is a standard like a ISO 7816 type of command, where you've got a class and instruction and the parameters and this. So here, if you want to use this read binary to read the data, so you just have to specify the address, and that's all. You get the data. So if you want to read, say for example, 20 bytes from address 0, you set the address to 0. So here the address is mentioned specified in 2 bytes, and LE is the length. This is the standard PCSC commands. This is for reading the data. If you want to update the memory, and keep in mind SLE 4442, you cannot update without the password authentication. So however, update is right into memory. You just have to specify FFD6 followed by the address, the starting address, followed by how many bytes you're going to write and the actual bytes, and the result will be 90. SW1, SW2 will be 9 and 00. And you might come across these errors as well. So you will get this error if you try to write without authenticating. Verify, as this command we're going to use to present the password. So before you write, it's very clearly mentioned here. So it says 4442 has got 3 bytes of PIN and 1 byte of error counter, and the 4428 has got 2 bytes of PIN and 1 byte of error counter. And again, I've covered everything in detail in my other videos. So to verify, to present the password, you're going to use this command. Give the PIN length, which is 3, and the actual PIN. If the PIN matches, if your password matches, you get a success. Otherwise, you will get an error. Interesting bit here is, if it's an error, you know that this particular tag, it can automatically get logged out after 3 unsuccessful attempts. So if it's a wrong password, you will get 63 followed by C followed by an X. X tells you how many more password attempts you got. So read protection memory. So you can read the first 32 bytes of this card can be protected from write. Now this command is used to read the value of all the protection bits. Somehow I just could not get what the documentation says here. So when I use this command, so I get either the entire byte, or I get I can get all the 4 bytes. So the best way to use this is, we know that the tag has got 32 bytes and each byte has got 1 bit, so that's a protection bit. So 1 byte can store the protection bit of 8 bytes. So you need 4 bytes altogether. So what you can do is read protection memory. So you specify the address and give the 4 bytes here. You give the specific address, you get all the 4 bytes. The next thing is is compare and protect. Somehow I'm not able to protect the memory or a bytes using this command. So I don't know whether it's because of this wording. So it says for SLE 4442 as a special protection memory. In this case, the function only compares the data. and it doesn't, I think it doesn't protect the data. So in order to protect it, you have to somehow get it done using the Synchronous API. So using this command you can lock, and again I explained this in detail in my other videos. Now these are the, and modify, okay, so this is the command you're going to use to modify the pin. So that's what mentioned here. You specify the old pin and the new pin, and if they both match, so they get, the pin is updated. And that's all. Now after that you got on I2C, which I'll not be covering here. And for you, the most important section is about this PCSC commands.